Hey Huskies, welcome to section 1.2, rate of change. This is your guided video notes, and as you can see, the objectives are below. We're going to talk about the rate of change or the slope. We're going to be talking about increasing and decreasing functions, the graphs of increasing and decreasing functions, what they look like and how to determine those intervals, and the function notation. So let's go ahead and get started. When we talk about the rate of change as a function, we're talking about the slope over a period of time. And so that rate of change is equal to, so we call it basically the change in this case, Q, okay, over the change in T. Okay? So basically the change, it's talking about the difference there. So basically you're talking about the difference, right, subtraction, the difference in Q over the difference in T. Okay, what this is talking about, it's the slope, but it's a new name. It's also known as the rate of change or average rate of change over an interval. We have a really nice new notation, and this is going to be some calc notation too. It's called change in Q or delta Q over delta T. That's the abbreviation of how we do that. So that is your slope, your rate of change, okay? And it's the change over an interval from A to B. What's the average rate of change? Because all these curves we deal with are not always straight lines, right? They're curves, so we can get an average rate of change over an interval. So that's your new notation, okay? So increasing and decreasing functions, this is also related to slope and rate of change, but when is a function increasing? Well, when both values are increasing, when f is increasing over that interval, the values, and when t is increasing. So f is increasing function if the values increase as t increases. So if the values increase, if the values of f increase as t increases. And I want you to think of that as being uphill, right? The graph, you're thinking about the graph looks like it's going uphill, like your parents. I used to walk to school uphill both ways, right? The graph, both variables are increasing, and we read that graph from left to right. How do you know f is decreasing? Well, the values, okay, the values of f decrease. So the values of f decrease, okay, so your y values are decreasing, your outputs, as t increases. So I want you to think about this, okay? The values of t are always going to be increasing. When you talk about increasing and decreasing functions, your independent variable is always going to be increasing. You're reading from left to right. You're just looking at what's happening to the y value. In this case, I think they call the f of t, or excuse me, the q value, right? Q, the output. Okay, so if the outputs are falling or the outputs are increasing, so that's what you're really paying attention to. So be careful. So if increasing is uphill, decreasing, you can consider, does it look like it's downhill? Do you want to sled down that hill? Okay, so as we continue, this is really important. How does rate of change relate to slope? Okay, so if your function's increasing, if it's going uphill, look at that. You can see that my hand, that's going to be a positive slope over that interval. So if you tell me a function is increasing on an interval, that means the slope over that interval is going to be positive. And likewise, if you tell me a function is decreasing over an interval, then you're going to have a negative slope. Okay, it's downhill. The slope will be negative. The rate of change will be negative over that interval. Okay, so those are a couple key things to relate average rate of change or the rate of change to slope, or excuse me, to increasing and decreasing functions. We've already talked about this, graphs of increasing and decreasing functions. Okay, the graph, if you look at the graph here in red, the graph here in red is increasing. Okay, and it's harder, whoops. Both values are getting larger. And if you look at the other graph, it's going down as the variable increases, it's decreasing. The output's decreasing. So the graph of a decreasing function falls when read from left to right. The graph of an increasing function rises from left to right. That's where you get that uphill and downhill idea. Okay? So let's look at an example of this, and we've only got two things left. The graph. So here is a graph, and many functions have some intervals where they're increasing, some are decreasing, some are not. They're just flat, okay? So we need to identify where this function is increasing and where is it decreasing. So where does the graph go uphill? So let's look at increasing first, okay? So if you look down here, you can see I'm going uphill, 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 up until this dot, and then I stop. So that function is increasing. Okay, we're going to say increasing from negative infinity to -2. And we always use parentheses when we talk about increasing and decreasing graphs. Where else is the graph rising? Well, if we look over here, see that blue dot looks at like +3, and you can see we're going uphill. It looks like it just continues on. Now there's no arrows, so I'm going to assume that just going to keep going to infinity. So from 3 until infinity. Okay. The other way you can write this is you could have said negative x is, you could have done an inequality notation here. So for example, x is greater than 3. Okay, you could have said x is less than -2 here as well for the increasing. Now let's look at the decreasing, and you only have one spot there, and that's in between. We're falling down. Okay, so we're decreasing. So we're decreasing on the interval from -2 to +3. So from -2 to 3. Now that's not an ordered pair. Okay, that is the interval. You could also have said from -2 to 3. Now we're talking about, notice with increasing and decreasing function, we're talking about those x values. We're not talking about the y values, the range. We're talking x only. Okay? So let's look at this last example, and you can see the average rate of change they talk about here, and they give you some definitions, and they want to know, find the average rate of change of the function on each interval from -2 to 4 to 1 to 1, and from 1 to 1 to 3 to 9. So you're going from -2, 4 to here. Now you can see that the function is decreasing on that interval from negative infinity all the way, basically it's decreasing all the way to here, right? Okay, and then all of a sudden, notice he starts to increase again. So you've got this two intervals here where you got a decrease and then it increases. So you have a decreasing and then it increases. So if you look at this, you're like, well, it's got both. But the average, you can see from here to here is going to be negative. So it's just that rise over run. How many are we going down, right? The rise and run. We're going to go from 4 to 1, so that's down 3. Right, and from -2 to 1 is +3. So it's down 3, right 3. So your slope here is -1. So the slope there is -1. Now on this positive interval, right here, they also want to know the average rate of change. It's not a straight line. It looks close, right? It's got a little hook in there. So how do we go? Look at our y values. We're going from 1 to 9. So we're going up 8 units, right? And from 1 to 3, you're going over 2 units. So that's up 8 over 2. So your slope there is 4. Okay? So that's how you can use your rise and run from a graph to find your average rate of change over a given interval. And that was the objective at the beginning. So if you have any questions or comments on this section, please type them below. And we're going to go ahead and we'll see you next time.